Greetings.
Hello. Yeah. Hello, everyone. Welcome to Blockchain Art for Monday, December 23rd. So, Tomislav, if you could just repeat again what the latest, what's happening with RCAT.
So I will be working on RCAT, and so I want to first see, what are the requirements, or what guys do you need for like the first thing, or what are you expecting? So now what we have is what's left for our song. So it's connected to also, I'm not sure that now is like all the code open source. So it's connected to these other libraries or third party, and what we had before. So I will extract like what is really the base for building some bigger systems. So and now we have Redis for cache, and we have RCAT UI, RCAT API, which are like client projects, which I'm not sure. Do we want to bring all of this complexity just as a part of RCAT? So yeah, I'm open for discussion on this.
Yeah, I mean, I've tried looking at the GitHubs before, but I find it a little confusing because I'm not exactly certain what these different components are, what they do. It would maybe behoove us to do a more of an in-depth technical dive into what these components do, and then we can see how they could be adapted to a more generalized framework. Because my understanding about what our song was doing was, yeah, there were these proprietary third-party codecs, and the whole model was doing something hyper-specific. And I think while what we're doing does have a certain degree of specificity, the ultimate sort of goal here is to develop a more generalized, replicable sort of protocol, right? Rather than something that's, and then that we then retroactively adapt for the use case of digital art, because it solves some interesting problems as far as how we think about digital property, right? How we push digital property into the future. But until we get to that point, we need to have sort of baseline protocols that will just work for everybody, and we want those to be as open source as possible. Even if we're working with our chain on that, the hope is that, like, using Rolang, this is something that works across any chain, and so really substantiates the thingness of something, without it being tied to our chain indefinitely. Like, the whole point of it, if I have digital property, it has to move fluidly across any chain that we're working with: Ethereum, our chain, Holochain. So what are the protocols, and how do we sort of prototype this so it will work, and then maybe get adopted by maybe a larger organization? Who knows? But in terms of like understanding how we can modify what you already have, though, it would require, like, should we look at the GitHub together and sort of you can talk about the things that are there right now?
Yeah, I didn't start looking at the code, so now I'm not sure that we want to in this phase. I'm not sure that is that we can see something useful, and so when you say protocol, the first thing is just to communicate with our node. So you can see this as two main commands that you are doing, right? You're deploying some Roland code, and you're reading data on some name inside the state, right? Because when you do the deploy, you're saying this is like a database, right? You're putting your code, and you're saying, I want to change the global state in this way. Here's the code. So and this is like a write. And the other part is just the read, when you say, oh, now I know, some name or in the state, and I want to extract the data. So this is like the two basic operation to communicate with the chain. So our first goal with RCAT is to simplify this process. And on
Well,
top of that, mhm,
okay, so basically, let me just repeat back what you're saying so I understand it correctly. What you're saying is that the ability of RCAT to read state changes that are embedded on the R chain on an R node.
yeah, and when I say state, I really mean on the blockchain,
Yeah, on the blockchain. So like
on the whole state. Yeah.
the whole state of the blockchain. So like what's not, but like as a specific entry, right?
Yeah,
In the block.
yeah. I mean, the rolling semantics of the rolling is you're putting something in parallel. So you have a state, and you are saying, and the state is the rolling code, the giant rolling code, and
Yeah.
you're changing the state in a way that you just say, oh, I have another rolling code that I want to put in a par with existing state.
Yeah.
And this is the concept of rolling, how it's working, you know.
And this is different than a
You're
normal
putting
database. Is this different than like a normal database functions? Like in terms of like how we read and write information? Because we're requesting
yeah,
state changes because like we're adding to a block, therefore we need
exactly.
consensus.
Yeah, but rolling is more general. So you have very clear notion when the state will change. So you're putting two rolling programs in a par, so together, right? And if there is matching names in both of the programs, right? You're sending something on one name and you're receiving something on the same name. You will get the reduction. You will get you will apply the change. If there is no matching, this is just another term in parallel to all the others. So the whole state is a bunch of rolling programs in parallel. So the concept is so, you know, so easy, and I think it's very good to understand, like this completely basic concept of rolling.
Wait, so you're saying like the entire state is all the rolling programs in parallel?
Yeah.
Oh.
Yeah, and that's it. You know, if you put another rolling program to all the existing, you're really saying, oh, Arnold, try to find matches for the names in this new rolling code in the existing, and try to match it. You know, if you find the matches, just apply the matches. You know. Put
So the
the
rolling code is like
sending
the
to receive.
semiotic. Is it like a semiotic container then, basically for the information? So like if we're just trying to encode basic, like let's say like registration data, right? Like name, year, like just like these basic kind of like variables, right? Like string variables to the but we want them indexable, right, by a certain parameter. So like if name, year, file type, like these are things that are basic fields, right, in our database that we want pushed onto an R node. What you're saying is they are surrounded by our Erlang code, right, which authenticates it,
Yeah.
and it's actually running as an executable program.
Yeah, and when you say these fields are also Erlang code. So there is no distinction between data and the code. This is something that is, you know, really valuable in Erlang, because there is no distinction. Your code is the data, and the data is the code. So
Wow.
If you just put at in front of rolling code, you're creating the data.
Okay.
So when you apply, when you deploy something, or you're really like querying the database, or you know, if you have the matches, you will update the database, or if you don't have matches, you will just, you know, you will not change, you will just update the database.
Yeah. Okay. I mean, I think I understand to a certain degree. I mean, I haven't actually tried coding rolling. I've watched Jim do it a little bit. Which is Jim okay, by the way?
Yeah, with the holidays, it's probably messing everybody's
Well, he
schedule up.
posted on Facebook that he had to go in for a procedure yesterday.
Oh, that I didn't see.
Oh,
Yeah.
okay. All right. We'll follow him later.
Yeah.
I think I saw him on Facebook yesterday. So anyway, so all right, so yeah, so because I haven't really done any rolling code, so like I know there's a sort of different way of thinking about programming, right? Like in order to make it more efficient for distributed computation, right? Like that's like the whole thing. And so basically what you're saying is we're not querying data sets or like or specific variables on the blockchain. We're querying whole sets of code. And if it pulls a match, or no, is that not accurate?
Yeah. You're right. I mean, you are querying the whole state that are already existing, right? In the same way as when you write your own part of the rolling code, right? You can write something that will be matched immediately, right? If you say I'm sending something on the name A, and I'm receiving something on name A, rolling interpreter will say, oh, I can just match these two and produce a result.
Okay.
So in the whole state, you have a bunch of channels that are trying to receive something and send something. But you will have this receives and sends only if there is no match between them. If there is a match, that there will be executed and result will be produced.
But would we need like a key or something in order to execute that code? Because like how do, like, if in terms of like securing a contract, we don't want anyone to be able to query my contract that I have. So like, how does that work?
Yeah. So yeah, this is a good question. So you don't have to think about this when your code is executing. So the entry point is when you are doing the deploy. Then you're proving that you have your private key and you can execute the code.
Okay, so they still asked you for a private key.
Yeah, this is why for each deploy you need a private key.
But the private, you guys haven't implemented tokens yet, so we can't use tokens as like in a wallet as a stand-in for a private key.
This is already implemented.
Oh, it is implemented.
You are using the Rev tokens directly. This is this is the resource that you need to supply to make any change.
It's like you need to burn rock, right?
Yeah, okay, rocks are now on the Ethereum, but Rev will be on the Archie.
Eric, what we have now is what's called test rev. So it's the precursor to the actual rev. So tomorrow, matter of fact, in our wallet session, since you're in the Eastern time zone at 10 a.m.
I'm in LA right now. So
in LA. Okay. Well, we created my Archain wallet, and there's a group of us testing tomorrow, and we'll be being issued test rev, and we'll be sharing it, passing it back and forth amongst each other, and checking our balance. So that component now exists for the platform.
Oh, cool. And that's at 10 a.m. Eastern time?
10 Eastern, yep.
Maybe if I'm awake tomorrow morning, I'll come.
Sure.
I'm having difficulty catching these like early morning meetings. I like woke up like half an hour ago. I'm like, oh shit. Like I almost missed the meeting, But I'm getting used to, like, as I haven't been out here in a while, so I forgot the whole like readjusting, like, oh, I have an 8 a.m. call. That means I have to wake up like at 7 a.m. and it's like
Yep. Yeah.
Anyway, so all right, so that's interesting. So all right, so Rev is like gas, and Rock is, but like there are no non-fungibles yet.
So just to explain, but the difference between rocks and revs. Rocks are the same as revs, but rocks are now on Ethereum. So when these rocks will be swapped to Archain network, they will call this revs.
Wait, they're on Ethereum?
Yeah. They're now whoever owns any rocks, it's still on the Ethereum network, because we don't have a Archain network running.
Oh, so they're tokens. So what are they? 721s? No.
ERC20.
Oh, they're ERC20s.
Yes.
Oh, I didn't know that. Oh, that changes everything.
This is just like a temporary to be able to to hold some tokens, right?
No, but that's what we wanted, Steve. That's what we've been talking about. Like, I would keep asking, can we please use the Ethereum blockchain for part of this? You know, because I wanted 721s. Or last week we were looking at a new protocol, the 1155s, which are supposed to combine. I don't know, like all. I thought 721s did all that, but like apparently these 1155s do all the stuff. But we want a non-fungible token, right, as something that can live in a wallet, right, that's as a stand-in for all the other relational points in the object, right, the addresses and distributed storage, all the different information things like that, like we have stored in different places. We want a token that points to all of them, right, that can stand in to unlock access to the files or whatever, whatever, or transfer sale, as long as you have this thing in your wallet.
Here's my thoughts. Maybe just kind of share what I recently found out, and Tomislav, you can correct me if I'm wrong. So in the world that we're moving to with Rev, what we can do is, so speaking to this non-fungible token, NFT, there's actually a protocol called the ERC 1155. I think we've discussed it to some degree here in Blockchain Art in the past. So the ERC 1155 is going to be different than the ERC 20 and ERC 721. So if you think of ERC 20 and ERC 721, those are for fungible tokens. They're all the tokens are essentially the same. And then in the world of ERC 1155, now we have non-fungible tokens where we have both non-fungible tokens and fungible tokens. So I relate this to an example someone put in the channel regarding in gaming. If you're a gamer and you're in a game and you want to collect a shield or a sword, this particular shield can have unique properties to it, power and magic and so forth at different levels, which makes this shield different from all other shields that are out there. So now it becomes non-fungible. It becomes unique. And we want to be able to take this non-fungible asset and store it and start accumulating. So do the same with the sword and so forth. So what the ERC 1155 does, it gives us this framework that we want to incorporate into with our using of RCAT and management of digital assets going forward. So perhaps what the discussion might be is, as we transition from ROC to Rev, how can we take now, since Rev is going to be the currency that we're going to use for cost accounting, where once we have a process kicked off, there's an associated cost with that. So a process can't run infinitely. It has to eventually wind down because there's an associated cost with that. So that creates this new domain that we're operating in. So in this domain, we can have an ERC 1155 non-fungible tokens. And so now we have to create this adaptation between the ArtChain platform and this framework of the ERC 1155. And actually, Lamuette, Raphael, who's working on the DAPI project, he is actually working on this an app or a link to connect the two worlds. So I think he's halfway there, or he's really progressing along. Wow. So yeah, he's in the CoLab channel, either on their general or one of the channels. He's provided an update as far as where he is at. But what started, and you can go to the general channel in CoLab to see this discussion that was initiated by Patrick M. Patrick Mockenridge, he comes from the gaming community, and he's tapped into the Engine Coin, which is a blockchain platform for
Tula?
the game.
Is this Cube Spawn called Tula?
Yeah, so that's his project that he's associated with. So and so ultimately there could be this connection. Engine Coin, they're the ones who created the ERC 1155 protocol, and they're able to allow gamers to get this magical shield, the magic sword, that are non-fungible tokens. But right now, everything is centrally stored. All the gamer owns is a pointer to the asset. The asset is actually stored on the Engine Coin server, so it's not distributed what we want it to be. So where our chain comes in, where our cat comes in, is, well, with the RChain platform, we can perhaps provide a more robust, decentralized way of managing these assets, these non-fungible assets. And not only that, we can manage them on a decentralized internet framework, which DAPI is. So Raphael is working on some of these pieces to connect the things together. So that's kind of the state of affairs. Yeah, so that's as far as what I know at this point in time.
That's really interesting, Steve. Wait, so just to back up, I just want to make sure I'm getting everything. So is what you're saying, so Lamouette is creating a port for 1150, or for the ERC 1155, so it will work with RChain, and we can use RChain's processing and distributed storage and computation capabilities to do all the back-end things, but we still have the sort of token itself that can be interchangeable on other exchanges, right? And sort of used in game engines and used in like art exchange engines, things like that.
Yeah, and I think, and I'm not quite clear. Let me just finish this one point. I think the application Raphael's creating might be that link to connect DAPI to the ERC 1155. I don't think it's to connect that RChain to the ERC. So
DAPI is just it runs on top of RChain, and it's like a
exactly. It runs on top, right?
But why would you? So go ahead.
So DAPI is using RChain as a storage, as a database. So and because RChain is distributed in DAPI, there is a logic to connect to multiple servers and ensure that you have correct data, and it's not from centralized server. And Raphael's implementation of ERC 1155 is really creating a rolling code that behaves like for this protocol. So
so he's emulating,
what this means?
He's emulating the 1155 standard in rolling.
Exactly. So the whole code is in just one rolling contract, right?
So it's not on the Ethereum blockchain. It's not on the Ethereum blockchain, but we're getting an 1155 token on the RChain, basically.
So the idea is that you're not creating directly token. You want to be able to have a protocol that you can create as many tokens as you like, right?
Yeah.
That was something I'm sorry. That was something that I missed, was with the ERC 1120 and ERC 721. In the fungible world, you have to have a smart contract for each and every token. In the ERC 1155 world, you just have one smart contract, and that governs all of these unique non-fungible tokens that are created. So one smart contract, infinite number of non-fungible tokens. So that was the one piece that I needed to add to get everything clarified.
And that's something that I didn't understand, that you needed a separate contract for each ERC 721. That actually doesn't make any sense.
But this is also something that we should not care about, right? Because this is related to Ethereum, and and how they are storing the data, and how can they optimize for these kind of purposes. So we don't need to replicate the whole thing exactly. right? This is not, this should not be the goal. We should just replicate exactly the protocol that we want to that we want to have. So we want to be able to create new tokens. And so I started from the point where how do you change the state, right? And you need to supply revs for execution. But this is not directly connected to your token that you want to create, right? And what does it mean to have this another tokens? In Archen, we have unforgeable names. Like when you write rolling code, you can very easily just create a new name. And this new name is unforgeable in a sense that it's similar to your memory on your machine. Right? You can tell someone, on this pointer in the memory, I have this data, but it doesn't make sense for someone else because, they cannot do anything with your memory. So in that sense, Archen is similar with this unforgeable name, you can protect the name in different ways. So you can ensure that only someone who create, deploy in specific private key can change or read or write on some name. And this is the core logic, right? You protect some part of the code, and you ensure that only some entities can change this code, this name, or the data on this name.
But how do they validate? They validate it with their wallet, or like what's the validator?
So as I said, when you create a new deploy, you must assign this data that your deploy, your code that you want to execute. So with this signature, you're saying, I have the rights to do this change, and the protocol contract, like this ERC, will validate that you are the owner of this name, or you have a right to change this name. So in a sense of assets, you can change the metadata of this artwork, right? Because you know that only someone who has this private key can deploy this code, because anyone can deploy this code, but the whole network will not validate and apply this change.
But where do I store my private key? Is it just a string, or what is it stored as?
It's the same as now in Ethereum. This private key is just a bunch of bytes that you own, and you need to keep it secure.
And stored in my wallet.
It's stored on your private machine. You are responsible to store it, because this data should not be on the chain, right? Because you need to keep it for yourself. Yeah. So you're only exposing the public key.
But then I guess the issue is when you go and sell the rights to that asset, then what are you doing? You're emailing someone their private key to that asset.
So this is the why these protocols are created, like ERC20 or ERC 1155.
You transfer the token.
Yeah, you really defining who can change the values on these names that you are creating. So I cannot say now, exactly how this works, but in essence, it works that you can send someone, you create a new name with your code that you deploy, and via this protocol, you send this name to someone else. And with that, you're really giving them rights to make some change, or, for example, to do something with the tokens, or transfer tokens, or this is like a capability that you are giving this user, and only this user who have rights to do any change of this name can do this with their private key when they create another deploy.
Okay.
Does this make sense?
Yes.
Idea is I will provide like a very simple example of the whole process, where where you can see all the whole the whole circle. And what Steve mentioned, we will do this with Arch and Wallet. This is like a
Tomorrow.
basic.
So I'll try and sit in on the meeting tomorrow. I still don't even have an Archain wallet. I should probably get one of those sooner or later.
No, exactly. Tomorrow we'll be creating a wallet.
Oh, okay, cool. So I'll come tomorrow morning. It's at 7 a.m. my time.
Because creating a wallet, what does it mean? I mean, you can just create your private key, right? This is something that you are doing off chain. You just use some code and you create your private and public key, right? And automatically we are saying, oh, we know how to derive rev address from this private key. So you have a relationship between private key and rev address. And what we're going to do tomorrow is when you create a wallet, you will create your private key, and then we will just you will receive some revs from someone else, and that's it.
All right.
You have your rev wallet.
All right. I mean, so this is good. So I think for starters, like we're gonna need like that is I think a very fundamental thing that is gonna be needed for what I think we're moving towards here in the art and blockchain group. We do need some way of storing these things. But then I think the next thing though is really about regarding RCAT is defining what data we want stored, right? That's basically the metadata that's describing the object. So just to give you like a very like boilerplate, like quick intro to just this concept, it's where the art object in this case is being described by its metadata. And that the metadata basically points to the thing itself and defines what the parameters, where the edges are of this object, which matters when it comes to things like obsolescence of codecs or file formats, and like how do we upgrade a file so it's still usable, right? Because unlike a sword or a magic shield in a video game, an art object usually has a very specific and non-replicable set of intentions surrounding it that's unique to the artist. And so it's about that relationship that you have to kind of manage. And in a way, it's been implied in the past, but what we're trying to do is encode it as part of a rights management system that the artist can use to manage their agency over the art object after it's sold. Because even unlike other types of assets, after an art object gets sold, the artist still maintains intellectual property rights over the object, right? And so things like, who does it get sold to? Where does it get exhibited? How does it get exhibited? Is there a fee for it being exhibited? These are all things, and the artist, and like the value, the escalating value of the artwork is still tied to the artist's career. So these are all things that we kind of need to think about. And so we're working off of where we've started sort of looking a little bit together at this legal document from the early 70s that I was sort of trying to see if everyone was interested in, so we could think about how we encode it into a type of modular rights management system based on established legal precedents. So unlike a lot of the other crypto art people that are operating, I'm actually interested in using established legal precedents, at least in America, rather than sort of trying to usurp
Something
it.
completely new.
Yeah, because like they're not really using legal precedents or aesthetic precedents. They're just kind of creating their own thing, which works technically. It works as a technical solution, but not really in relationship to art, as I define art. And my background is I'm a media artist. and theorist. And so I've been, you know, working in and around the fine art world and the academic art world for, you know, most of my adult life. And so I, you know, I have like a very specific orientation, which in some respects is kind of not, it's not the most open interpretation of what is or isn't art, you know. But I'm sort of looking at this in terms of the larger cultural, kind of global cultural environment and saying, how do we build a tool that really works for artists, you know, and not like people that are trying to just make money selling badly drawn memes, right? You know, like any of the, I don't know if you're really familiar with like Super Rare or any of these blockchain art startups, but a set of tools that we can give to people, right? And they can manage. It's not owned by anyone. It's just a set of ideas that can be implemented in any way, but like that it's open. So like artists aren't being taxed for creating digital property, right? It's like we don't like, because like right now they're being taxed. If I want to edition an art object through a pre-existing company, they're taxing me for access to the blockchain, which is just kind of absurd, right? Which if you follow the logic of disintermediation, it gets harder and harder to act as that middleman. So I'm sort of trying to jump the shark a little bit and say, well, all right, let's create a free set of tools. And then maybe there's other things that can happen after we've created those tools, but the baseline needs to be established. And so with RCAT, I mean, my understanding of RCAT is there's two things, right? There's the metadata, and then there's the file itself, right? Which can also be stored on chain. Ned, I've talked with Ned about this, and it seems like it's very expensive to store a file, a large file or set of files on our chain.
So yeah, we exactly don't know, you know, how much this will cost. I mean, idea is that you store everything on the chain. That's the whole point, right?
But like, I think for you know, music is a little bit of a different vertical than a fine art, right? Because there's much less people accessing an art object than a music file. So if I'm Beyonce and I, you know, I'm putting a new song up on our chain, yeah, of course that's going to drive traffic, right? You guys are going to have a ton of people accessing this file, and it's going to drive you. I mean, I get the logic of doing that. Art, no, definitely not. It's like it's predicated on exclusivity and scarcity, right? In this case, perhaps a false scarcity. Not to say there aren't middle grounds. Like there's art pieces that like YouTube that artists, you know, would put up on a video on YouTube and then sell it based on how many views it had on YouTube, right? Or, you know, there's art pieces that are websites that like can't really, the piece can't work without a public being there to interact with it, right? So the way you archive and the way you curate that work is different than like a painting, which, you know, there's Van Gogh paintings that exist in storage lockers that no one ever gets to see, but people every couple of years someone sells at a Sotheby's auction, right? And it never leaves the warehouse. It's just in this climate control, you know what I mean? And like it's just
yeah, this is pretty bizarre, yeah.
So so there's a lot of different what I'm trying to take into account is a more lateral interpretation of what what art can be, rather than using a reductive construct or about that's technologically driven and saying, well, we've got tokens, so therefore we should tokenize artwork and turn art into tokens. And it's like, well, no, that just is a complete reduction of what art's function is. You know, it's like saying that basically anything that can't be tokenized in this specific way isn't art based on this system. And I want to avoid doing that as much as possible. So regarding RCAT, what we need to do is create an itemized list of metadata, I think, for starters, that is flexible enough that lots of different types of people can use it. And we need a user interface to make it easy for them. Like everyone, we've been doing a lot of stuff with these chat bots in Discord or Keybase, but we need just like a basic UI drag and drop user interface, like a HTML interface, to allow people to edition their work using this system.
Hmm.
And basically, so independent of whether it's RCAT or if it's on the Ethereum blockchain, we have, let me show you, hold on, give me 1 second. I'll pull up my really ugly drawing that I haven't fixed yet.
Yeah, I was thinking that we can create some very simple single page applications that you can publish on GitHub or directly on Archie, which you can manipulate and adjust for your purpose. So
Yeah.
and Arcat is like the backend, like Arcat is something that is between you and Archain, because you want to cache something or have better performance, at least now in the beginning.
Here, let me just do this. All right, can you see this?
Yeah.
Yes.
So this is this is not the whole thing, but this is part of the model that I've tried to draw out. I promise I'll make a nicer model at some point, but basically the model that I was looking at uses IPFS to create a hashed file location, right? And then we have a separate DID formatted JSON file, right, which we upload zipped to that hashed file location, right? In that JSON file, we have, so there's the hashed file, we hash a file, we upload that hash to a DID formatted JSON file, right? So that's like kind of our start. We have two things: the metadata describing what the hashed file is, what's on it, all this stuff. Then we upload it to distributed storage network, which gives us its own hash, right? And then that then produces three things. We have a certificate of authenticity, which is the descriptors, right? Which is also mirrored in the JSON file. This is just so it's indexable using a standard DID. And then we have a smart contract, which predicates the sale, how the object gets sold, which is tied into the definition of the object. So basically, the certificate of authenticity is like a legal document defining what the art is. So this is a 1280 by 720 MPEG-4 video file that can be upgraded to 4K as long as there's good color, bit depth, resolution, and blah blah blah, like all this stuff. And then the smart contract is tied into the definition. So if you try and sell the file without using the smart contract, it nullifies the entire art object, because the definition of the art object is this is a thing, and this thing gets sold via this smart contract, right? And part of the stipulation of the smart contract is artist resale royalties are built into it, among other things, including like executive rights management things. Like I can veto the sale. Like if my collector wants to sell to this horrible oil warlord someplace, we can veto this and say, no, I don't want my work owned by that person, right? And this is all then represented, all these hashes, these things are hashed, and then are represented as a type of token, which lives in a wallet, which can be traded, right? So the token is not the thing, it's just the thing that makes it easy to sell this thing, right? If and when it's appropriate to do so, and lives in a wallet. This is the base, the baseline system. There's other things that are gonna have to like exist on top of this, including like, how do you say, rights management, like what
ERC, Electric Rights Protocol.
Yeah, well, the protocol management, like how do we track who's viewing this file and who gets access, and like are there browser plugins? Like people are working on that, which will be like, okay, your browser lets you see this because you have this token in your browser, But for right now, I'm just focused on what's the most fundamental substrate that we can have, right? So the issue here is if we're going to use RChain instead of IPFS, that's fine. But then in the case of a fine art object, we need to shard it, because no artist I know is going to be able to afford to store their art object on RChain as it currently, according to Ned, And so we need to be able to create private shards where just the token and the metadata is being stored on the main node, but then we have a private node for storing and serving the files.
So my question is, this token is created. So are you imagining having only one token for all the artwork, or when you create as an artist, when you want to publish your arts, do you create your own token for for yourself, or you create a token for specific art piece, or
Well, I think like if I'm understanding this correctly, we can use an 1155 where like an artist creates their own 1155 token, but it's embedded in the standard, which makes it interoperable and tradable, right? So like the metadata and like how the token executes is all embedded in that token. But then like the token itself is a semiotic container, can be interoperable and exchanged on a normal exchange, a token exchange.
Right, all the criteria that you want to create and set for that token, which is unique to that token, can be added to that one smart contract. So, right, so that's the idea, that one smart contract is able to manage all these varying non-fungible tokens.
So Thomas, does that make any sense?
Yeah. I'm still struggling to understand, how. So you're not the artists are not directly connected to specific token, right? To this token, or I mean, you can exchange token between different artworks, right? They are not connected with, you're not differentiate between, different tokens related to different art pieces, right? Not care about this kind of connection. You want to have a freely accessible token that you can exchange for any artwork created from this contract.
Right? Yeah, wait, I'm not sure I understand the question completely. So, like, is the question like, are we would it be the idea would be to create one like art token which everyone uses, and
yeah,
versus like having, I'm not sure I see the distinction between, like, as far as I'm concerned, the 1155 is the one token that everyone's using. And then what information or what parameters are embedded in that token is defined when the token is created.
So with this kind of protocols, you can create multiple tokens, right? For example, now we have rocks for Arching tokens on Ethereum, right? ERC20.
Mm-hmm.
But there is lots of different ERC20 tokens, and you can exchange them, right? But not directly. You cannot, exchange this directly on Ethereum and say, oh, I will, somehow do this. You need some kind of external exchange that will say, okay, I will give you this much tokens of of rocks for some other token, right? This is not embedded. This is not embedded in the protocol, right? In the
a token exchange,
or token exchange, or whatever. You're selling, you're giving some tokens to me, and you just say, oh, now you are the owner of this amount of tokens.
Yeah, I think that's isn't that what they refer to as like atomic swap? So, I have, and I'm relating it back to this world of gaming, and perhaps, this could be extracted to what we're talking about here. So say, I've got a sword and Eric has a shield. I want to trade my sword for that shield. So we swap these assets which are represented by these tokens. So that's what's called an atomic swap. Now, in the world of ERC20 and 721, you have to have an exchange. Since these two tokens are different, you have to have an exchange to facilitate that. But in the world of ERC 1155, it's all within that contract management. Now we're able to swap back and forth as many times as we want assets, which is part of this ecosystem that we've created.
So I would first like to make a distinction. We should not care about different implementations, right? In Ethereum, we have the different implementations of how this internally how this works, right? But this is not important to the logic how token is working, right? Because you want to store it in different ways, but because you cannot do as you said, in ERC20, you cannot easily create multiple instances of this token, or I'm not sure what. So, but what kind of logic that we want to implement? This is something that I'm not completely sure.
Maybe I'm just like not understanding the nuance here. I'm not sure I'm understanding. Yeah, I don't think I understand the difference. Like, because it seems that like this idea of the atomic swap versus selling tokens on an exchange, like what's the difference? Like, yeah, you can, if me and Steve want to trade our tokens, we can just do that informally, or someone could set up an exchange that allows for you to buy and sell ERC 1155s. How is that different than buying and selling a 721 on an exchange currently? Or like any, you know what I mean? Like, or us choosing to trade an ERC 721 that's a CryptoKitty. Like I have a CryptoKitty, Steve is a CryptoKitty. We trade CryptoKitties, even though his may be worth more monetary value than mine. If he likes, you know what I mean? We can still trade them without money, like it being exchanged to USD.
And you can do this on external exchange, right?
Yeah, or I'm pretty sure I can just send the 721 to his wallet. Like,
so the Steve's example in the game, right? You can exchange, if you're in the same game, you can exchange your weapons, right? But if you have a different game, right, you cannot do this, right?
But
So
in the world of the ERC 1155, you can go from game to game, and your assets go with you. So now you're the gamer is the owner of the assets. And in the gaming world, they call this the multiverse. So there's a collection of 15 games, and you can go from game to game with all of your asset swords and shields, and so that's an added feature to this world of ERC 1155. I don't know if that helps the discussion.
Yeah, because I think the way to look at it is the token in that case is non-fungible because it's totally coupled with the asset itself. And so therefore any platform that supports that token allows that because the token is the thing. Or the ownership of the token is the ownership of whatever the asset is.
It represents it. Yeah.
Yeah. And it doesn't, the one thing I find interesting is, all this can be done in our chain, with smart contracts and, the shards have an ability, right? If you, like Greg talks about in his new white paper, like forking, which may be a better term is sharding, you could set whatever the economics of your shard is. If you wanted to create kind of a shard that was non-fungible, because it's all ruled by the smart contract is how I see it. So whether you're using a token something as non-fungible to represent some ownership in an asset, or a smart contract that maybe in a more kind of liquid code-based fashion determines how that asset is used, right? You know, and so it seems like our chain, I mean, to me, this is like all this kind of like really theoretical stuff in our chain that we need to drill down into to kind of figure out, you know, in this great platform, how do we actually implement like all these like super advanced computing ideas? But because it seems to me that you could do all this with our chain, you know, in smart contracts.
So if we create, so you have the main shard, which is the art chain platform, and off from that we create the blockchain art shard, and we decide as the four of us we want to create one smart contract, and it's going to have certain properties, and it doesn't have to be any particular protocol that exists. You know, it doesn't have to be this 1155 or some other number. It's going to be different. It's going to be unique, but it's going to be ours. It's going to create this framework, but we're going to incorporate some of these functionalities of these protocols in there, but it's going to be different. So in this shard, now we can start to do all of these things. We can create the rules of the game, of what we want to happen and what we want not to happen, any type of restrictions and so forth, because it's all within our little our domain, or this shard that we create.
Exactly.
Okay.
Well, and so what's interesting
about
about? I'm sorry. Go ahead, Tomislav.
I mean, when you say shard, from the rolling perspective, you don't think about shards, right? This is like implementation of your network, so you should not care about. But as you said, you are defining the rules of the game. So if your contract creating tokens, right? Some other people can create another contract. Right, and when we are saying tokens, this is like just a number that you are storing somewhere, right? You're saying, oh, you have this amount of, you know, this token, you have this amount of this token, and you're storing all of the histories, you know, who give token to whom, and you know. So if someone else create another contract for some other purposes, we cannot say, oh, we can easily just exchange numbers one to one, right? Because you know, we are not recognizing this another entity, another contract. This is something else. This right? This doesn't have connection directly from our contract. We didn't create these numbers.
So a couple
Does this
thoughts.
make sense?
Yeah. Although, hey guys, yeah, it's top of the hour, and I have another meeting to get to.
Okay. Thanks, Ned.
I just want to wish everybody happy holidays.
You too, Ned.
And yeah, lit my menorah last night. As I got the Christmas tree going too, so you know. But happy holidays, everybody. I'm actually, after testing tomorrow, I'm going to be taking off for about a week or so. So
Cool.
I won't be back next Monday, but the Monday after.
Okay.
Cool, man.
Enjoy the holidays.
All right, thanks. Happy and healthy to everybody.
Peace.
Thank you. Okay, so Tomislav, let me just repeat back what you said in a little piece of what I was thinking. So when we think of this shard, it's our network. You know, in our network is each of us we're connected together, and that creates our network. And the three of us agree that we're going to create one contract, which is going to do all of this that we want to do as far as managing the assets. Now, a couple things could happen. Somebody else, so a new smart contract can be created, which is similar but a little different. Now, it could be two things. It could be in a different network, not in our network of the three, so that if it's in a different network, you know, it's out of sight, out of mind. But say with the three of us, we have this one network smart contract that we've created, and I decide, hey, I'm going to create this new second smart contract, which is going to be similar, a little bit different, and put it in our network. So now what happens? So maybe that's the scenario that creates the question mark, where now you have two smart contracts. They're similar but not the same. And how does management of these assets come into play?
I mean, why would we create a second smart contract, Steve?
Maybe I want to be nefarious. Maybe I've decided that, hey, I just don't like the way the games are being played, and I want to create my own smart contract, which gives me the edge somehow. And it's in this world of trustlessness, where no one trusts each other. They just trust the code, just trust the software. Things like this could happen. And it would perhaps be in a broader network of not just 3, but now we've got 100 validators running, and someone wants, even though everyone agreed to run this one smart contract, someone says, hey, I'm just not happy. I'm going to create a second one and try to get everyone over to that new smart contract. So how does management of assets happen in this new environment?
Well, I don't know. That doesn't really make any sense to me, because if everything is hashed up front, right, and all the hashes are pointing at each other here, then if you tried to create a new smart contract, the hash from the smart contract isn't going to be reflected anyplace else, right?
So when you say a hash from smart contract, what do you mean? This is cache of the uploaded artwork, right?
Yeah, but the smart contract itself has a location on the block, right?
So you're breaking up. Can you please repeat?
Oh, I'm sorry. Can you hear me now? Check 1 2.
Yeah, I hear you.
The smart contract itself has a location on the block. Yeah.
Yeah, but I think I understand your what you're thinking about. So when you deploy the code, rolling code, it executes on the network, and you don't really care where is stored, in which block or what is the hash of the block, or and I mean, this is the good thing, because you just care about how the state can change, how your smart contract can change the data that it holds, right? So in your smart contract, for example, the first deploy of the smart contract will, I don't know, create some initial tokens, right? You can say my contract will create 100 tokens, and I will have a way to for you to upload something and get some tokens, and someone else can create a completely identical token, but the state inside the contract, inside the smart contract, it's it's protected with only these functions that you anticipated in the beginning.
But it's also it's been time stamped, right? So
yeah, you can do whatever you want. Right?
All this gets time stamped. When it gets uploaded, it gets time stamped, so it's indelible in that way. The whole concept of non-fungibility is that it's a unique thing that happens in time and space, right?
Yeah, what I want to say, you don't have to care about all of these things. This is already implemented with the Archain protocol, or Archain network. So you have a timestamp, you have everything. You just need to put this into a smart contract, and all the other things you're just using directly from Archain.
And so protection against fraud is built in.
Yeah, because you don't have to work with all the hashes. You have these unforgeable names. You just create a new name, and you can protect this name so that only you can, for example, write something and all the others can read. And then you can implement this in your smart contract that, you can say, yeah, but I can write permission to someone else. And this is the purpose of this ERC special contracts, because you have very strict rules. How can you access to this interstate?
But this is only on our chain, right?
It's similar to on Ethereum. Yeah, it's very similar, but Archon gives you some additional ways. How can you
because I think that the thing is, even if our chain has the ability to against forgery, right, built in by this through this naming process, every other chain may not. And so by us encoding sort of redundant hashing into all the places that sort of coalesce into the distributed object, that creates a type of portability for us, where it's like, okay, even if we don't need to do this on our chain, it may need to happen someplace else. So therefore we still want to have this sort of extra redundant mirroring of all the hashes and like the hash locations, timestamp, like hashing, timestamps. These are important things just on a protocol level, I think, for us. Even if our chain has solved this problem really elegantly, we'll use that. Like, we'll absolutely do that, but we still need to have these other things baked in. Does that make sense?
Yeah. I see your point. Okay, I'm not sure that I can, now grasp the whole picture, and
I don't either.
Well,
or which places you exactly using caches, and yeah, we should definitely talk about that more.
Well, yeah, so there's a hash. So basically, if we load all of our
hash,
we hash a file, right? We were looking into a protocol called oh my gosh, spacing. Steve, do you remember what we were looking at with the hash?
The ERC electronic rights transfer protocol, or not that?
No.
Oh, you're talking about the with the substrate, the agoric.
No. The agoric was ERCTP. No. The hashing thing. It was like
Do you mean this hashing that Dan mentioned in Discord? When you can, create a hash and then compare.
As far as the type of hash, like a SHA-256 or a SHA.
Yeah, we found this amazing like program that was like sort of like a protocol. I didn't list it here. LOL.
It is not just a hash, right? It gives you some ability to compare different.
Yeah.
You can compare similarities between different hashes.
Yeah, and it uses like all the different hashing types and like allows you to sort of hash nested files. I'm totally spacing on the name, but it was like really cool. Anyway, so here's the idea though. Like, so the file or the collection of files hashed with the metadata, right? Although actually, I'm not. Now I'm rethinking this. I don't know if the DID JSON file gets hashed with the art files or as part of the art files, or if it's separate. But let's just say, for the sake of argument, we hash the file, and then that hash goes into DID, right? Then that hash is uploaded. That hashed file is uploaded to distributed storage, right? With the JSON file, and those two things are given a location hash, right? Which is also then, well, no, then you can't upload the hash back to the DID. So maybe the DID stands separate. Anyway,
I mean, maybe you don't have to look at the whole file, right? You can hash some of the fields and say, these fields are hashed, and I have special field to store the hash.
Yeah. That's exactly what we would love to do. I wasn't sure if that was possible, but that, like, I think that this thing that we were looking at may allow you to do that, right? Or maybe it's a separate file. But the idea is, so then once it's uploaded to just IPFS, there's a location hash, right? And then once you have that location hash, we now have 2 hashes, right? So then we can then take that and create the certificate of authenticity, which includes all the metadata, a written description of what the file is. Like, this is a performance where Eric, you know, throws black paint at a white wall, and then takes a picture of it, you know, or like whatever. It's like, it's just like, we're framing it out in a narrative description, right? That goes into the certificate of authenticity, as well as the, like, how long is it? What's the medium? Is it a video? Is it a still image? How do you upgrade it, right? These all, how can it be exhibited, right? Like, all these things get stipulated in this legal contract, right? Which is the certificate of authenticity, which also is storing provenance.
So can I ask you, when is this certificate of authenticity created, and who creates this?
After IPFS, right? After it's uploaded, like, IPFS feeds us back a location hash, right? And a public-private key for the location for that file. Then we would create the certificate of authenticity from that data.
So my understanding of IPFS is that the hash is really, the hash of the file is really the address.
Yes.
I mean, this is like, this is the same for torrent files. You have a hash, and this is like, this is the address of this file.
Yeah. So, like, the location hash is given to us, and then we can take that.
You don't need to wait for this, right? You create a hash directly for this on your machine, right? Mm-hmm. You don't need to you know, to give a file to someone to get the hash, right? The point of hash is that you can do it yourself. You must be able to do it yourself.
That's what's happening up here, is we're doing it ourselves up here. But then the location hash, right? So now we have a location hash for where the file is. And then these 2 things are created, the certificate of authenticity and the smart contract, right? Which are mirroring these 2 hashes, right? As well as ideally each other. So, like, everything is sort of looking at everything contains all the hashes for all the other things.
But I'm worried in this certificate, you know, I can change and put whatever I want in this certificate of authenticity.
After the fact? Once it's been created, then I mean, once you can put whatever you want into it, but then once it's been created, it's indelible, right?
But who creates this certificate? The artist? I'm not sure that I'm understanding the purpose of this certificate. So, can you say something about that?
The artist makes it by selecting what information they want in it, right? And we give them, like, maybe a set of options that are based on this document here. The artist's reserved rights transfer and sale agreement, right? So they're sort of picking from a list of options here that we've created, filling in forms that like, sort of supply us with the data we need, right, to fill this form out. And then that gets uploaded.
So in the artist's interest is to specify all the correct information in this certificate of authenticity, right?
Yeah, it's on them. It's on them. And maybe their gallerist helps them do it too. You know what I mean? Like, it's possible that it's like they're not doing this themselves. It's because the way art works right now, an artist I'll make a video file, but it's not really sellable until a gallerist editions it. So you still need these gatekeepers, these physical people, like, or a museum director will collect it. But, like, it's the editions. It's not something that I necessarily do by myself. I could do this by myself for archival purposes, but ultimately it's like the gallery is the one that, like, presents the work and gives the work its value.
I see. So I'm just thinking, you know, do you want to protect somehow, you know, that you cannot do whatever you want with this? You know, you can steal someone artwork and just create your certificate and say, oh, now now I have this in my smart contract, right? So
can you steal a certificate though? I don't know. I mean,
you're creating all of these things, right? You're creating your artwork, you're creating DAD file, you create this certificate. So all of this, like these are like input in your in this smart contract, right?
yeah.
And this can do anyone, right? Everyone who thinks that it has some artwork should be able to do this, right?
In theory, yes. But it doesn't necessarily give it value. What gives it value is its participation in circulation in the art exhibition world, the gallerists, the collectors. I mean, the perceived value of the artist's career. These are all things that are not able to be encoded onto a blockchain, But yeah, in theory, anyone that wants to deal with digital property, period, should have access to this and be able to edition their digital property using these tools.
Okay, so yeah, this makes sense. So for Arcade, Arcade is really this part of the game, right? How can you upload something, communicate, get the data, all these things, and it covers all of these things, and the smart contract can make a different different way of how would you like to exchange all of this data.
Yeah, what the contract is doing is it's pointing at these other spaces, right? These hashes, and saying, all right, I control the transference of these things and stipulate the terms and conditions of its sale and resale and usage, ideally. And so in order to access any of this stuff, you have to go through the smart contract. So I don't know that this is forgeable because it's also reflected, the definition of the object is reflected here. So even if I copy the file, even if I edition a video piece through this system, and then I just email you a copy of the video just so you can see it, right? It doesn't matter because the actual artwork is the thing that was hashed here, location hashed here, defined here, and now connected to these two things, right? So even if you upload your video version of what I sent you and put it through the same process, it's not the same thing because the actual video file like I own with this ERC721 token is identified through all these things. And there's a public record of it being owned by me or by the collector. So it'll be hard for you to forge it.
So that emailed version of the video, if someone obtained it and they wanted to sell it, they couldn't sell it because it wouldn't really be the art piece. It's a copy of it, but it doesn't have any value in itself. The artwork that has the value is the version that is associated with the certificate of authenticity, which is stored in a specific location.
Yeah, and furthermore, it's been tweeted or something like so. Like we do a thing where we actually tweet the ownership of it when it's been a first edition. So there's a public record. Although the blockchain itself serves as a public record that this thing was created, there are some stipulations where it gets more complicated. Where what happens if the artist if we need to upgrade the file, then we actually have to go through this whole process again. And like, how do we upgrade the file, upgrade the contract? There are things that will problematize that. It's like, it's not just this, it's going to be this in perpetuity. And we need to figure out, how to upgrade or transfer ownership or like destroy a file, create a new edition. Like there are things that need to be sort of, stipulated. Maybe it involves like some type of multi-sig system.
So you said you want to have compatibility between different chains.
Yeah.
So,
I mean, I
yeah,
don't
you should
see
be able to.
Go ahead.
Yeah, but I'm just thinking, you should be able to verify if if you how can you move from different chain, from one chain to another, and how can you verify where is now your
Yeah, I don't know.
What if there were two phases to this? Now I'm thinking very high level. So the first phase is working within what our chain and what our cat can do, using the unforgeable names as the form of security. So you create this prototype, of the smart contract in this in our chain. And then by doing that, we start to work through all of the intricacies and challenges, so that in phase two is the version that can be passed around from a blockchain platform to blockchain platform. Right now, that functionality doesn't even exist. So even if this were created, you still couldn't connect from our chain to hollow chain or.
Yeah, no, I agree with you 110%. And honestly, I think in a way, like, I think we've been focusing on the wrong things, because I think this is ultimately the thing that we should be focusing on.
Yeah.
And, like,
so
encoding
perhaps,
this.
yeah, maybe narrow down of what we're trying to accomplish. So maybe we get and maybe if you send Tomislav the contract. So this is it's about 4 pages, and I could understand it, and it's more written by a lawyer. If this happens, then you do this. If this happens, then you do this. It's very understandable, but it's not it's not the world of blockchain.
I'll be right
Yep.
back. Hold on, just give me 1 second.
It's in this world of I have an art piece. I wanted, so this little hard drive, this is actually a work of art, and I sell it to you, and in this contract or in this transaction, I get 15%. But now you own this piece of art, and then you want to sell this to Gary Coulter, and then when you sell this piece of art to Gary Coulter, you get 85% of the transaction, and 15% comes to me because I'm the creator of the art piece. So all of this is what happens in the real world. So this contract was created in the 1970s, even before computers were sitting on people's desktops. So perhaps if, as Eric was saying, if we make that more of the focus of what it is we're trying to engineer as far as what the smart contract can do, and in this phase one, just work within the confines of what RCAT can do. It has all the securities with forgeable names and so forth, and we create something. This something it exists and it actually works. So, it's this version of me selling this to you and then you selling it to Gary, but now it's in the blockchain world, and it's all governed by the smart contract, and funds are allocated and reallocated automatically into our wallets, and it works and it exists. So and I think if we create that as the scope of the project, we will have accomplished. We will have created the prototype. Now, what Eric is talking about, he's been working on this for about 5 years or maybe 7 years, and he's coming at it from a whole different vantage point. He's trying to create the ultimate solution. Well, that ultimate solution may not, all the pieces for the ultimate solution to actually work together don't exist now, and they may not exist for another 3 years. So instead of us trying to create the ultimate solution, we can't do it because those pieces don't exist. So we shelve that, and then we work on the smaller piece, which everyone can understand and which can be accomplished as a prototype in our chain. So I think that might be a pathway to success. So, you know, I think of us working together. So I'm just catching Tomislav up on kind of what all the discussions and compressing everything down from the past few months into 5 minutes. And ultimately, I think what you just said, Eric, before you walked away was, hey, there is an ultimate solution out there, and someday it'll happen. But right now, let's put that on the shelf until all these connecting tissue pieces get created, because right now they don't exist just yet. And let's work within what we know, what exists and what has been created. And I understand that, you know, all of that is in the confines of the ArtChain platform, but we can create a prototype. But it's not the ultimate solution. We recognize that. We know that that's not ultimately where we want, but it's something, and it creates a success. It creates a win. But if we do that, we're going to get smarter. We're going to by creating the first prototype, this version, we're going to be able to understand what we knew in order to create the ultimate solution. And by the time we get to that, maybe, you know, in a year or two, all those connecting pieces will have matured, and that will become more of a reality.
So, all right. So here's the deal. Like, we can't, Tomislav, is it possible for us to set up a situation where we have a private shard that is serving video files?
So when you say private shard, what exactly do you mean?
Like 5 to 10 people are all we all set up like a Raspberry Pi or something, or like a little computer, and we're all serving the same distributed file, right? That we're all locally hosting. So like this would be a stand-in for like the artist, a collector, and like a gallery, let's say, right? And like we're all sort of instantiating the distributed object together as co-creators. We're
like a private network.
A private network that's co-creating a specific set of objects, right? And then we use RCAT if we can use ERTP, right, as like the language, you know, using rolling, to format the artist reserved rights and transfer and sale agreement as a type of smart contract, right? That's operating on the sort of set of fields, of variables that we need to encode to substantiate the object in this way. So so we have this information. It's fine. We're using RCAT. We're using rolling and RChain to do this. But like, how close to this can we get while not paying a shit ton of money to store the file on the main RChain net? Does that make sense?
Oh, okay. So yeah. This is not a problem, right? If we want to run our private network, we can do it, right? Without problems.
Like I'll buy a little shitty little Windows or Linux box, you know, and like all 5 of us will do that just to run a test node, so we can all store the file together and then see how that works.
This is exactly how we now run testnet, right? We have like testnet, we have sandbox net, and you know we have different networks where we are testing the ArtChain. So yeah, we can definitely say, 5 of us will run our node, and we will have our own network. Yeah. And this means that we have our own ref supply, right?
Our own what supply?
We are creating our own network, right? We are creating Genesis block. We can completely say, you know, how rev will be, you know, distributed, or you know. But so like, maybe I can say, you know, how network is starting.
But like, does it
You
have to
just
be? How does like can the rules? I mean, all right, maybe I'm oversimplifying this in my head. I'm thinking about it kind of like BitTorrent and Google Drive had a baby, and so we're not really exchanging rev or any value for the storage of the file. We're just all, can we all just agree that there's no value that gets exchanged? We're just storing this file, right? And then, but then the on mainnet we store all the metadata and the executables, right?
mm. So yeah, now we don't have sharding, so we cannot connect this as a shard, right? We can just create another isolated network from the mainnet.
That has its own, that operates on its own rules, basically.
Completely on its own. We can create our own like revs, right?
And
But
so
you don't want this, right? You just want to have another shard that operates a little differently from the main shard, and we don't
maybe
have this ability.
maybe that's an, you know what, maybe that's actually the best idea, because then what happens is, in order to transfer the ownership of something, you actually have to transfer your server. You have to sell them the server that you're using to store the file, and then it becomes a physical. There's a quote by this guy who's he used to be the senior digital art archivist at the Museum of Modern Art in New York, and he said, every time a hard drive stops spinning, the myth of materiality. Oh shit. Myth of materiality. Every time you reinforce the myth of immateriality somewhere, a hard drive stops spinning. I love that. Like,
Yeah.
so I like,
Yeah.
yeah. So I like this like idea, because if we do set up a private network, so like, that's just for video art, right? So I've got a group of maybe 20 artists that we can start. Once we have this set up, here's the thing. Like, once we have this set up, I can then bring in a group of about 20 artists to start using this network, right? Now, the thing is, it's not going to drive traffic to the main network, but these artists need a cheap, secure place to archive their media, and they're willing to support each other. Like, everyone is willing to go out and buy a 2 terabyte hard drive, right? Connect it to a Raspberry Pi or something, right? I mean, that would be ideal. And then we were all serving each other's artwork and creating a distributed archival storage network for that work that we then can operate on. So if any of us do sell our work, it's stored on our network, and then the collector buys a hard drive to also store all the work from this collective of artists. I don't know how you deal with the escalation.
I mean,
like, it's like all of a sudden, because at what point do we then force everyone to buy another 2 terabyte hard drive, or like how does it work? Like, it becomes dicey after we hit a threshold of data storage, and video files are very large. So we're going to hit that threshold pretty fast, right?
Yeah, and then you just mentioned some of the problems that ArtChain is also aware of. Greg was explaining this because you can create many different entities who has this data, right? Who running this network, and how can you check if if this is only one entity who created all of these virtual entities, right? Because you don't want to have all of these machines, all of these instances of Arnold on one machine, right? Because you can have one hardware which runs hundreds of virtual machines. Mm-hmm. So how can you be sure that your data is really stored on different machine, different hardware? So this is why you choosing, like, would you like to have your own private net or some global net that it's secured in I'm not sure how to say, more decentralized way where you have more guarantee that is working as you expected.
In
Because
certain cases, you know, it's like, it's also very specific on use case. Like right now, the 20 artists that I would work with, their work isn't worth enough money to warrant its storage on mainnet. Like if my work was worth $100,000, storing on mainnet and having it distributed among 10,000 servers would be worth the cost of that. But these aren't artists who work has that type of historical value. Like it has a lot of value in relationship to art history, but it's not really market-driven video artwork. And so, but it's very important historically. So how do we create a solution for them that then maybe makes it so the work is collectible, and then all of a sudden the work will have value, right?
Yeah. I mean, what you said totally makes sense. You know, you create your own network, but you only store hash on the mainnet, right? Because you want to have data which is, you know, which is part of the same smart contract with all the others, right?
Yeah, I mean, it can just be the token that's stored on the main network that refers to all the hashes of everything else that lives in the private network, you know?
Yeah.
Yeah,
I mean, this is how this token is working on Ethereum, as Steve mentioned at the beginning.
The token moves around on Ethereum, but like we're all the computation stuff is happening on our chain that determines if and when and how it gets moved around.
I mean, for this 1155 token, yeah. All the metadata are stored somewhere else on the centralized server because it's too expensive.
To store it on the Ethereum blockchain?
Yeah.
So it's stored. So it's stored on our chain. All the metadata is stored on our chain, and it's pulling the metadata from our chain.
So I see metadata as something very small, right? We can store it directly on the main.
Yeah, that's what I thought.
And then you can really say, yeah, for example, we can say you can choose where you want to store your data. So you can say, oh, my artwork is very expensive. I will store it completely on the mainnet. But we can also support different other like backends to store the data for like IPFS or you know some like Google Cloud or so whatever you want. You know, you just say, oh, this is the URL of my data if you know if you want to access it, or you can store on the private network because you know you are collaborating with 20 other artists and you have your own network.
Yeah, I love this.
This can be part of the metadata that you just say, it's too expensive for me to store data directly on the chain, on the main chain. I will store it on IPFS and also on this private network.
Mm-hmm. Yeah, but at that point, we don't even need IPFS though. I mean, like ideally, I wanted to use IPFS initially as our private network, like a private IPFS network, but if this serves the same purpose, it doesn't matter if it's a private network. It doesn't matter whether it's IPFS or our chain. It just like it's
whatever you like, right? You can add multiple storage so you can be sure that you know the data is accessible.
And our chain is faster in theory than IPFS, right?
You mean to store the data?
Yeah.
The complete data.
That was what Ned. That was what
to say. Yeah.
That was what Ned and Greg were telling me.
When we get there, we're not there yet, but that's one of the special features of our chain is the high transactions per second. So as the platform matures, that transactions per second will continue to increase. So that's the advantage of that's the value proposition of our chain, of storing your asset on chain is it's the speed at which everything is uploaded or downloaded. So you know, but it's, I would imagine, yes. So it'll be faster than IPFS once we get to full maturity.
because here's the thing: if we are able to create private networks and then really encode these toolkits into them, right? That creates a highly usable and scalable, I think, solution. Like all of a sudden, maybe the Museum of Modern Art will want something like this, right? Which we could then provide them the tools to, or like help do, like we can create an open source toolkit, but it actually provides something that we can offer because it's like a hardware and software solution that is private, it's scalable, it's redundant.
Yeah. I mean, yeah, this is how I look Archon, you know. Why should I care about, you know, all the distribution of my database, right? I build application and I just start Archie network on different different computers, and you know they are all part of the same network and they will be synchronized. So I don't need to care all of the, you know, synchronization and everything. So if one machine is going down, I will just spin a new one and they will synchronize, and you know.
Yeah,
So
I mean, I don't know.
it's
For
not
some
just
reason,
about, yeah.
this is maybe I don't know. Maybe I'm just like I'm in Los Angeles right now, so I feel more relaxed. But I'm much more open to this idea, I think, than I was a few months ago. Like, no, I like everything you're saying. I think this is great. I mean, I'm just wondering how we should move forward with this, because I think Steve can sort of attest, we've been working steadily since July or August.
Yeah.
And we've been having a lot of sort of like circular conversations and trying different things. We were using, Gary was working with us for a while and was using Keybase. Where's Gary, by the way? Is he around?
He's probably enjoying the holidays. He's certainly around.
Yeah, we were like working with Keybase quite a bit and like these chat bots that he was really psyched about. But, you know, ideally, I think like what you're describing, like setting up a test net for ourselves and then figuring out how to encode these. The problem is like, who's going to encode these contracts? Like, is there enough interest in the RCAT community to start encoding some of these ideas into the sort of simple executables? Like,
so Steve mentioned Raphael. He's now doing like moving this ERC 1155 to rolling. So we can see we can start from his first version, and you know, see how can we, you know, use it and maybe modify for our purpose.
That's fantastic. I mean, it's fantastic. I mean,
And,
it seems like these things are really coming together then. Like, is there an RCAT work group that I should start coming to?
Well, what we have is the DApp Developer Working Group, which is actually 3 p.m. Eastern Standard Time.
Today?
Yes, but we haven't.
I don't have it on my calendar.
Tuesday, I'm sorry. It's Tuesday. So on Tuesdays, we have a 10 a.m. Wallet Developer Group, and then a 3 p.m. DApp Developer Group.
Oh, yeah.
The DApp Developer Group hasn't been well attended for the past few weeks, and I haven't been able to attend. So it's been kind of loose. But if we get enough of these projects going, then we'll get more attendance. So what my thought is, perhaps if we can engage Raphael into this conversation and kind of explain to him where we're at, where we're going, because even, you know, with this idea that you have in this private network, you know, you have, say you have 20 servers going, but using DAPI, you know, he's creating the alternative internet. So now these 20 servers can be, well, I'm probably getting it in over my head, because I think his is connecting with our chain, which is with assets stored on chain. It'd be interesting to ask if his DAPI application can also work with servers that are off chain, and that I don't know. So, because that was what we're thinking about with our private network is for artwork of lower value, storing the data on servers off chain. So it's less cost to no cost. But if there's enough of those, say, you know, there's 100 of these servers, and
Shards?
we're creating our own. So I think what Tomislav was trying to get to was the sharding capability doesn't exist just yet. It won't exist for a few months. So we have to come up with something, a workaround until this world of sharding exists. So this workaround is a private network. So this is a hard drive. Your 20 friends each own a hard drive, or a server, a Raspberry Pi, which is serving up. And then with DAPI it connects to it creates this network of all 20. So if someone wants to look at the art piece, it goes to a server and it retrieves data and pulls it up. Now, if one of the servers goes down or 5 of them go down, with DAPI, it adjusts and it finds the server that's working and serves up the asset, the information. So, but DAPI is connected with on-chain assets. Perhaps it can work with off-chain assets as well. That I don't know. We'd have to speak with Raphael, but I think as far as we start working through these issues and connecting them together, as far as what needs to happen, engage him. But I think so certainly here at the blockchain art time we can so the question was, when do we want to start building the pieces? I think just use this hour for the blockchain hour and invite people to attend, to ask them questions. Can you do this with your app, or does this work? So I'll just reach out to Raphael, and maybe next Monday, if he's available, bring him into the discussion.
Yeah, I mean, I'll try and show up tomorrow morning. I mean, is it possible, Tomislav, to run a node on a Raspberry Pi? Is it powerful enough?
Well, K1 is done. Is already tried that, and it can be done, but not directly from our current releases, right? We are not building for Raspberry Pi, and it needs some tweaks to run it. So yeah.
So basically, like, if we just get like some simple Windows servers, some Windows computers, like if everyone gets like a little like what are they called?
Yeah, for private network, yeah, it doesn't have to be too it doesn't have to be too expensive hardware or something. But
I mean, do they need to have GPUs?
No, definitely. But
Someone
need some memory, right? At least 4 gigabytes, I think.
So we can get like $100 like little netbook, or like little what are those little toaster boxes?
Are you thinking like for the real first version, or just for testing?
Well, I mean, if I'm going to make people buy hardware, right? We want to keep it as cheap as possible. And we want it to be usable for both a test and then basically to transition to a main net, because I think ultimately what we want to think about, it's funny, I actually sat on an airplane with this guy recently who worked for one of the companies that does, oh my God, what is it? Oh, it's like there's special types of chips that they use for facial recognition processing. So it's like a special type of Which one?
FPGA. These are like programmable chips.
No. Yeah, programmable chips, and it shifts like how it does its processing based on it shifts its internal structure based on what type of process you feed it. Very flexible type of like CPU. It's like not a CPU, it's not a GPU, it's like a third thing that I wasn't familiar with.
Probably you think about this FPGA. This is like a field programmable array, something like that.
Yeah.
Programmable field. Yeah.
The only reason why I know what that is because Tomislav, you mentioned that this morning at the Casper stand-up.
Oh yeah.
You were talking about the chip, so I went and Googled it, and I'm like, oh, okay.
Yeah, because
if
we're gonna like, it's
we cannot run Arch in that.
Cannot. Okay.
Yeah.
So like, I guess the thing is, it's like thinking about like, all right, what's the most easily accessible like hardware solution that like someone could go to Best Buy, buy something for like under $200 and run a node, right? Or do we have to like start thinking about customizing solutions and like creating our own boxes that we then ship to people, which isn't the worst thing, if like, let's say again, like if you start thinking about like larger institutions, right? Like the Museum of Modern Art or the Guggenheim that have global art collections, right? That are starting sizable digital art collections. Maybe like all of a sudden you create almost like an art chain that is a global system that is redundant across all of the world's cultural institutions, where they just have like massive server arrays that are mirroring all of the collections in all the museums. And even though MoMA owns like X, Y, and Z, and Guggenheim owns A, B, and C, their collections are still cryptographically mirrored on each other's servers in case of any type of like, I don't know, like meltdown, calamity. And so it basically, but the thing is, you don't want to tax them on the main net just to have those collections. Like they want to be sort of privately stored and secured. And, with the price of hardware coming down, I mean, I can envision something like that in the next 5 years being actually possible, like within the realm of like, okay, it's cost effective to actually have redundant collections across all the world's cultural institutions.
This is exactly, you want to have some, you want to trust, you want to have trust between these entities, right? And this is why you want to have like blockchain, so that you just run your own node and you are sure that all of the data is, completely correct, right? Although this is not the mainnet, right? This is like your private
It's a thing. It would be a private network. Like it'd have to be a private network because you could not possibly afford the astronomical cost of petaflops of data, being stored on the mainnet. It's just, that'd be insane. Like,
exactly.
Um,
or this kind of need is also between banks. Now every bank has his own service and store all of these accounts and everything, but they don't trust between them. How can you trust this other bank? So if you have this kind of protocol or network, then you can say, oh, I trust this this other bank because I know that I have consensus is on top, and there is strict rules. How can you change the state, the accounts balances?
Yeah. Interesting.
So to answer your question, for buying your own hardware, it's so you cannot run it on Raspberry, but you can have like very cheap hardware to run it, right? You can buy like very simple. I don't know. You can have a few gigabytes of RAM and very cheap processor.
They sell like $200 to $300 mini computers, that artists use for installations, like video installations or whatever. They come
maybe check. I think it's even cheaper to buy real like motherboard and processor. It's maybe cheaper than these smaller PCs. They are usually a little more expensive because they are in
compact size.
So we can definitely have like cheap hardware to run it, or maybe if you want to run it in the cloud, this is also like an option.
Well, so like
you can have for $5 you can have a machine.
$5 a month we can have a machine.
Yeah.
So then what it becomes like on like IBM, like I know a guy at IBM Software. We actually were originally in this project years ago. We were working with them. They were going to be like our storage solution. They have like a program where they'll give us free storage for a year, called the software like incubator. But I'm wary of going to the cloud because like that could scale up and get really expensive really fast. So then like everyone that does it basically is paying $5 a month to run their own machine in the like on Amazon servers or something like that.
Yeah.
I mean, I guess it's like not
maybe
like
you don't want it. Yeah.
Well, I don't know. Maybe that's not terrible though. It's like $5 a month. Think about it. Like and they're dealing with the hardware, and then we're just actually like running the network remotely. Is it really that cheap just to run your own isolated box? Or is it, it's shared, it's shared?
It's a small machine, right? I think two gigabytes of memory and one processor.
But is it because I have web hosting using DreamHost, right? And I'm pretty sure I'm on a shared virtual machine. Like I don't have my own dedicated hardware, and I pay like $100, $110 a year, let's say, for that. Who does $5 a month for your own dedicated box?
Oh, you can search for DigitalOcean is
DigitalOcean,
and Hetzner is another company that is in Europe. That
Hetzner?
You can. I can share the link. They have even cheaper machines for €2.50. So
really?
But they have only service in Europe. So, but yeah, this is also like an option. You can choose whatever is more appropriate for you, right? We don't need to say you must have your own or you must use cloud.
Yeah, no, I mean, I like this idea of running both, basically, where you can buy your own hardware or you can serve it on the cloud. Because like for a lot of folks, they don't wanna.
Yeah, I mean, from some purposes, you really want to have your own machine, so you can be completely sure that all the data is completely private.
Oh, it's cool. Steve posted
like you're having your own databases in your network. You want to have it completely private.
Yeah, no, I love that.
Yeah, that was the what Kayvan was running on Raspberry. Last year.
Interesting. Hardware setup. So it is possible then.
It is, but some of the libraries are, need some tweaking. So I'm not sure exactly what is the problem, but
I guess if we do this on the cloud, if we do this on the cloud, then we can just create kind of a plug and play deployment that we can give to people to run when they set up their instance.
Yeah, completely. Yeah. We are already thinking about that for to create templates for different clouds options, right? You can run it on Azure, on AWS, or different cloud providers.
Oh, really?
So you can just spin up your node and
Oh, that's really fabulous. Okay. I love this as a way, because like then it's much easier, I think, to say to people like, hey, all right, sign up for this thing. It's $5 a month, and we're going to create our own private art block on this using maybe for now we can try SoftLayer because it's free. I don't know how much they charge. I can call my guy and ask him about that. But all right. So then I guess is the conversation really about Steve, are you still here?
Yeah, I'm still here.
Maybe then like next week we should start talking a little bit more seriously about the artist rights and transfer sale agreement. Because if like all this stuff is sort of happening anyway, I mean, we can start figuring out, or is the best thing to start talking about is using the DAPI implementation?
Well,
we can really use testnet for our first purpose for create this smart contract and test it and see how we want to work.
Right.
So we don't need to think about all of the machines and running everything. We can just connect to testnet and
Yeah, for now, until I think if we get the smart contract created and running on testnet, because testnet it's 10 nodes, so it's distributed over 10 machines. So if we get that proof of concept working, then the next step would be, okay, now let's expand beyond those 10 and start getting personal hardware. and expanding it that way, or getting it onto the cloud. You can start to explore these others. But I think taking that that 1972 uh, uh, artist rights contract and converting that into a smart contract, and then as Tomislav starts to get those final pieces of RCAT created, then the pieces come together. So now we've got something that will work on the 10 nodes of testnet, and we can start to actually start using it. We can start experimenting. I've got a piece of art that I've created, and I've sold it to Tomislav, and we'll have our wallet created. So then we can use, we'll use TestRev for now, even with if mainnet gets launched, use TestRev for working through these scenarios. I sell a Tomislav, I get 15, and I get and then he sells it to Gary Coulter. Tomislav gets 85% of that transaction, and 15% comes back to me as the original artist. So actually start using a prototype. So how long it would take for us to get there, remains to be seen. But I think we're identifying those pieces, that roadmap to get us there.
So you're saying we should work on these things in parallel, like the artist's rights and transfer sale agreement, and working with figuring out RCAT and DAPI implementation simultaneously.
Yeah, well, I mean, Tomislav, he's that's the core development, and Tomislav,
Yep.
is here today, kind of getting oriented, getting requirements as far as what he needs in order to finish out to get RCAT up to where it needs to be. So I don't have that core development expertise, and Jim and Gary, they're not able to contribute to that effort. But what we can do, Jim, he knows Rolang, and he can start to create the smart contract. And as that, so you have with the artist's rights contract, that's the language of what we want it to say and do. We just need to take that and convert it into Rolang code. So now we've got that digital representation of it. Tomislav and the core dev, they're working on the RCAT. All we can do is give them encouragement and any guidance, and if they need any requirements. But they're working on that, and at some point, those pieces will come together.
Yeah, I mean, I guess I still want to understand more about what RCAT, how we can sort of work with RCAT to develop the things that I mean, it's really just in my head in a very simplistic sort of way. All I see it as is a series of fields or variables.
So yeah, so RCAT is not something that is critically right now, right? Because we can start playing with just one web page and directly connect it to our node, without any RCAT, without anything else.
But what is RCAT going to actually do? What is RCAT going to do?
RCAT is more robust solution when you want to when you want to store a large amount of data, and you want to have some cache in between, because getting the data from Archen.
Oh, this is going to include the caching.
Yeah. This is what RCAT is providing, some kind of layer in between that you can you can implement caching and different things. Right?
Oh, I thought that was something that was talked about. I didn't realize you guys actually were going to do that.
I mean, now this is very simple. We have a ready server in between where we are storing when you first access the data from Archen, it will be pulled from Archen and stored in the cache. Right.
So basically it's like a streaming service then, basically.
Yeah, because the purpose of RCAT was to be like a backend for RSOC, Android app.
Okay, so that's actually, so that solves like, that's actually like solving a much higher level issue than actually for us than I was even ready to deal with, because I'm like, well, like, okay, how do we actually create the front end viewership framing, right? Like how, like that's secure, a secure framework for viewing art. That was like something I'm like, all right, that's like way in advance of where we're at. So this is actually like solving that problem before we even get to like the other things.
Yeah, definitely. I mean, for now we will have a web API, so we can, you know, I mean, we can do it. We can now access. So we cannot access Arnold directly from the browser. So now we will have this web API, so that we can connect directly to Arnold from the web browser, and as Steve said, we can start working on this smart contract, and we can work directly from the browser without any ARCAT in between. And we can develop the whole solution, you know, and then when ARCAT is ready, we can just plug it in and, you know, have it like
Oh wow.
more robust.
Oh wow.
But we can start. What I would like that we create some kind of a very small framework that we can, you know, in each week we can, you know, improve and to have some kind of base for
Yeah, what I'm trying to figure out is just because like we've been sort of operating like I'm not like the best with but we've been sort of acting in a more of an exploratory manner, and I'm wondering if it would behoove us to create some type of loose thumbnail plan for like what, just in terms of thinking about like, all right, what are the, even if we don't do these things in this or in a specific order, these are the things that we need to think about doing on our end. So then we're sort of moving in sort of lock in a sort of a linear trajectory, right?
Yeah, exactly.
I think there are two big. Yeah.
Go ahead.
I'm thinking that maybe there are two main things to develop, right? This smart contract, which must replicate the contract that you mentioned, and just the JavaScript part, like the web page, which is, you know, communicating with this contract.
Yeah, and if we develop those things, then basically we can just hook that up seamlessly with RCAP because we've developed the smart contract enrolling. So then it'll be interoperable automatically with RCAT.
Yeah. RCAT is not really concerned with rolling, right?
It's not, but they'll work together because we're basically describing the object. Everything that the smart contract is describing will be, if we use I don't know the right identifier, then like the hashed file in our chain will be then fit. So basically, in a sense, what RCAT is doing is we're saying, all right, like if I'm sorry, let me go back to the this chart here. I'm not sharing my screen anymore. Hold on. Screen share. There. Okay. So then basically what's happening is if I was to maybe make these a little smaller. Our cat lives here. Which is basically, our cat is fundamentally dealing with viewership, right? Or like what would the word be? Like it's dealing with my ability to see the file, to stream the video, right? That's basically what it's dealing with. It's not dealing with rights management or anything else. It's just dealing with the streaming.
Yeah. Like you want to speed up what Arnold is, you know, it doesn't have right now. Right.
So this is basically the final step in the process, is the streaming service. But that's basically all that RCAT is dealing with, is the streaming of media files by creating a cached server in between our chain and the viewer and the client browser.
Yeah. And expose some kind of API that is more accessible for clients.
Oops. All right, so that all this stuff still holds, and none of this functionality is being replicated in ArtCat. So we still need some type of ERTP smart contract system to mediate between who and how someone can access the ArtCat streaming.
Yeah, and this is the main thing that we need to develop, right? So our focus should be on developing this smart contract in Rolling, so we can implement all of this. Our intention, how this should work.
I mean, because the other thing is, once we do develop this framework, I mean, in theory, then our song will work too, right? Like this framework is usable for music as well. Like I'm looking at this from a fine art object and saying like, okay, digital file is a thing. It has thingness. It's individuated, right? It's given an ontology, but that doesn't mean that the rights management system can't be used for one-to-many or replicability in the sense of like, I'm an artist that wants 3 million people to stream my song, or watch my music video. We're dealing with this very limited use case because it's, in a way, it's kind of easier to create scarcity because you don't have to deal with the logistics of streaming to 3 million people. But this is going to empower those artists as well to use this system. And then basically my sort of fever dream, if you will, is that musicians are going to be able to use this system to insert a smart contract in between themselves and the distribution platforms like YouTube and Spotify and Pandora, right? So it constitutes kind of like a form of soft unionism where like I'm saying like, okay, Spotify needs our music, but I want to enforce a smart contract that makes them give me a higher percentage of the value that they're creating every time someone streams my song through Spotify.
Yeah, and in the future we will have much a richer way of how can you do this, because in Rolling you can have a smart contract that accepting another smart contract.
Exactly.
And, we will have a type system that you can really specify what this contract looks like that you are accepting. This is not possible right now because we don't have this type system, but we will have it, and this will be very powerful when you can inspect some unknown code, and you can run it as a part of your smart contract because that that is safe. All the important executions that can happen. You control, you specify how these smart contracts should look like.
Yeah.
But for now, we can think about in simple terms that you don't supply another contract, but you're supplying exactly some kind of data that you can easily inspect.
Yeah. And that's like, I think the point of using DID and trying to incorporate protocols into this, because that'll help create that interoperability, like between the identifiers, the descriptors that we're using for the files. Because eventually, like if all files are using DID, right, and like we're using some type of machine learning algorithm to index them, all of a sudden these things become searchable.
Yeah, and from that perspective, storing DID in some structured format inside the Archain will also gives us a way to query the data, because Rolling is the ultimate query language. So in the future we can store all of this data in structured format. Like we can store the image in some structured format. We can extract the visual parts in the image, and then you can search the image. Or
Yeah, totally. Man, I gotta find that service we were looking at. It's in my note. I'll find it later and I'll post it. Are you on our Discord chat now, Tomislav?
Yeah.
I'll post it. It's somewhere in there.
For hashing, right?
Yeah.
Hashing.
Yeah, I'm just looking. Oh, Jim always posts these really crazy looking pictures of me when all these videos. I just look so crazy all the time. ISCC. It's called ISCC. ISCC.codes. Here, I'm going to copy this and I'll put it in the chat.
Yeah, I remember we discussed that
This
a while
is like
back.
complete.
I don't remember exactly what that was. Oh,
It's a hashing protocol framework that allows us to use multiple hashing protocols, like ways of hashing, to hash nested files in different ways.
That's what you were trying to think of earlier.
Yeah, that's what I was trying to think of earlier.
Okay. ISCC. Okay.
Yep.
And Jim, he's started already on the smart contract. I don't know how far along he is, but he's been working on that. So if we could find out where Jim is at on the smart contract, and then as far as the other piece was a web interface, is that correct? As far as to input.
Well, yeah. I mean, ideally, we would
Yeah.
have like a web page with like some like text fields and drop down menus, and like an upload button where you can like upload your file or set of files, and like basically we want this to be as like sort of seamless as possible. I'm not saying we have to get there soon, but like if other people than us are going to use it, ideally there's just a simple web interface that's just ugly but functional.
Yeah.
Yeah, we can definitely start from there, and if you have this kind of very simple page and API with specification, you can give to any web developers, and you can create whatever you like.
Okay.
Yeah. So, all right, this is great. So I guess for next week, Steve, so we'll start looking a little bit more closely at the smart contract next week. I just want to look, I want to see what the holiday schedule is, because I have a feeling maybe it may fall on like New Year's or something. Next week, so next week is December 30th. 31st. Well, I'll be here. So, I mean, I don't know what Jim and Gary are doing. Ned said he won't be here. But maybe we can meet with the guy from DAPI.
Yeah.
And,
this is like a good start for creating this smart contract.
Okay.
And Tomislav, where are you based? Are you in Europe?
Yeah, I'm in Croatia, in Europe.
Oh, you're in Croatia. Okay, cool. So what time zone is that? Like, are you in, what time is it there?
+1 UTC.
So what time, what is your time right now?
It's 9 p.m.
It's 9 p.m. Oh, wow. So you're like 9 hours ahead of us.
Oh, you're in a Pacific
Oh.
time. Yeah.
Pacific time. Yeah. Okay. So you're 9 hours ahead. So you're 6 hours ahead of like New York City time.
New York time. Yeah.
Exactly.
Okay. Great.
And I think the Rafael is also in the same time zone as I. He's in France. So.
Oh, okay, cool. So this is an okay time for you guys to meet for the next like few weeks?
Yeah.
Okay, awesome.
So what I'll do is I'll once this video gets processed, I'll upload it to the link to the blockchain art channel, and I'll tag Raphael to have him take a look at it, just kind of review it at his convenience, and to get his comments as far as what piece DAPI might be able to play in this, and then if he's available a week from today, see if he can join us for this session. And I'll touch base with Jim as far as where he is at with the creation of the smart contract. So maybe
We should also make sure he's like okay. I mean, I think he's
Yeah.
like in the hospital or was in the hospital. So like I have a feeling he may be out of commission for a little bit.
Yeah, I'll take a look. I'll wish him a happy holidays and see how he's doing, and based on his condition, see what the appropriate step would be. But that would be the ideal, is to start getting the smart contract and that creation of the smart contract into our conversation. So twofold, it'll help us to make sure that that smart contract is creating the following the artist's rights contract that we're wanting to follow, and help us familiarize ourselves with Rolang as well. So ideally, you know, if we can get comfortable enough with Rolang, we can read through this code and understand what's happening, and say, oh, wait a minute, what's happening here? This is reverse, or this is, I think if we can, as a group, familiarize ourselves enough on reading Rolang, that would be helpful for us all.
Yeah, totally. I mean, I don't know that I'm going to ever be like an amazing developer, I've kind of like let go of those notions of grandeur from my level. But like, one thing I can do is, I understand the macro like frameworks, right? Like I understand how code works. I'm just not good at the semantics of it. Like, so like oftentimes I get caught up in, like I know what I want to do and I know how it works. I just don't know what the right syntax is to do it.
Well, you play an important piece to this, because and then with your friend Lauren Van Heusen, you know what you want the smart contract to do. Ultimately, it's supposed to do this thing and this thing and this thing, and if it doesn't work that way, then it starts a conversation. As a coder, as a developer, a coder can create the code, but they need direction as far as what do you want it to do. So that's where everyone plays a role in delivering the final product.
Yeah, totally. And so for next week, I mean, I'll give a read through again of the contract. I want to like sort of, so we're going to let go of ISCC, like the hashing, like, I mean, I guess we can sort of work through these things step by step, which we did do like, I mean, Gary did like a simple like hashing based on like what his computer, like but we weren't using the ISCC protocol for it.
We can do this directly in the browser. Maybe not ISCC, because they're using some C code, which maybe we can translate this to WebAssembly and run in the browser. But if we can start from something simpler.
Yeah, my thought is, let's just keep it simple and get something created, and kind of test it out, and then we can get. This is a process of iteration. Iteratively, it'll get more complex and advanced. But if you have a foundation to work from, and everyone can see it and understand what it does, you're in a good place. A common ground, and that's kind of where I see us needing to be. Because, like you said, Eric, we've been discussing this since July of this, 6 months. And, it'd be great if we had something tangible in the next month or two that, we can actually say, look what we got. It works. It doesn't work perfect, and it doesn't do exactly what we want it to do, but it works. And that would be a great spot to be in.
Okay, cool. So why don't we end here? And I guess we can be in discussion. I'll see you guys tomorrow morning, maybe at our wallet thing. But in terms of thinking about uploading a file to RCAP, Tomislav, when do you think that will be a possibility?
So we maybe for ARCID this will not be very soon. But as I said, we don't need to use ARCID directly, right?
Yeah, I think the main priority right now is getting the mainnet. So mainnet, is hopefully sometime in the first quarter. So once that key milestone is achieved, then resources will be reallocated elsewhere, to such as ARCAD and others. So it's on people's minds, but it's just a lower priority right now.
And Tomislav, you're working on mainnet as well?
Yeah, now we are working on fixing the bugs and hardening and this kind of stuff.
Okay, so you're part of the core group of developers for ArtChain.
Yeah, yeah.
Oh, okay, that's cool. Along with Ned.
Well, Ned is really working for co-op, so I'm not sure if, you know, so I'm not under contract right now, so I'm, you know, I'm more like part of the community, and you know, I started as a core developer, I think last month.
Oh, okay, okay,
So
cool.
I posted a link with rolling extension for Visual Studio Code.
Oh, cool.
If you want to try rolling, this is like a very easy way to, you know, to test it, because you don't have to install anything except having the Visual Studio Code as an editor and Docker as a, you know, as a software to run containers on your machine.
Cool.
So maybe we can in the next session or on the after the session after that we can go to you know, how can you run rolling on your machine very easily. So you can just you can grasp very this very simple you know, rolling syntax is pretty simple, you know, and easy to understand, because if you don't have any programming experience already, then you are in the better position.
And that's
It's
true.
different from the current languages.
Exactly. The least, if you're starting from scratch, you're in a better position than someone who's been programming in Z++ or Fortran or something else, because it's a whole different animal.
Yeah, I mean, I have some experience with like processing, which is like a JavaScript kind of variant language. But most of my programming experience is with a software called Max MSP, which is for programming like sound synthesizers and interactive video. And so it's like a visual programming language where you kind of connect.
Oh, I see.
Like you connect like physical like objects together in like complex ways to make things like kind of happen. It's not very efficient for certain types of functions like iterative loops, things like that. You can't. It's just not really set up that way. But it's for creating signal flow sketches. So that's like most of what I do because it's easy. I understand how that works.
So there is a like translation from rolling code to some process schematics that you can, you know, visualize rolling code. So, you know, in the future we will have this kind of visualization of rolling execution, and
that'd be sweet. I'd be interested in that.
Yeah, that sounds awesome.
We also need this from debugging, so we are now talking about that. You know.
Cool, guys. Well, all right. So it's 12:30 my time, which is 3:30 Steve's time, and 9:30 Tomislav's time.
Yeah.
So we should.
Yeah.
You're the time oracle.
Yeah, I'm the time. So we should go. This has been lovely meeting you, Tomislav. I'm really excited. I was actually I haven't been around for a couple of weeks because I was traveling, and I got really caught up with the end of the semester in Buffalo. So I
didn't know if you will be today. You know, so
no, I'm here now for the next month or two. I'll be here. Once next semester starts, things always change a little bit, but I'll be here. I'm basically in Los Angeles, and I'm working and doing all my working. I'm working on my master's thesis right now, so I'm just sort of working on that. But I'm available for more meetings now, so I'll be around.
Cool.
So
okay, I will join also. Yeah.
Fantastic. Cool, guys.
Very good, and I'll work on coordinating as far as, you know, getting others in, to join the sessions. So
cool. Thanks, Steve.
This will be good. Yeah. All right. Thanks, everybody, and I'll post this video here on the Blockchain Art channel here sometime later today.
Brilliant.
Great. Thanks, everybody. Happy holidays.
Thanks, guys.
Take care.
Bye bye.
Bye bye.